Do you like horses? I think they're great. In this case, this horse is going for a jump under a parabolic arch. Wow. That is mounted on a wall. So I'm going to draw it. Should I draw a horse? Look at that horse. Oh, they have a slightly longer nose. Oh, okay, this is terrible. Anyway, this horse runs along and jumps over this rod AB under the arch and continues on. And now it's frozen. Oh, there it is. It can stay there. So we know that this arch rises 2.43 meters above the wall. Okay, so this wall line here, we can consider that x-axis, right? And let's consider this point Q the starting point. So that could be our y-axis, and it has a height of 2.43 meters. And now we're given a model for this arch as h of x equals kx times 3.6 minus x. Right, k is some constant, and h is the height. So instead of y, actually, I should put h of x, right, the height of the wall. And its horizontal distance is measured from Q. Yep, which is what we put. All right. What else do we know? Just having a look at this model, is it a positive or negative parabola? So it's apparent from the diagram, right? It's a negative parabola. But if we were to expand this out, we would get negative kx squared as one of the terms. And when we have a negative in front of x squared, it's a negative parabola. Now k could be a negative number as well, which would make this positive. But from the diagram, we know that's not going to be the case. Do you know what we call this form of a parabola? Right, it's called x-intercept form. It just looks a little bit different, right? So one x-intercept is at the origin, or x equals 0, and one x-intercept is at 3.6. So what would the distance from the origin be at this turning point here, at this peak? Right, that would be halfway, or in this case 1.8. So we found a point, right? We know that this point at the top here is 1.8, 2.43. So whenever we have a model, in this case, we don't actually know what k is, try look for a point. Because if we can find a point on the graph, in this case the turning point, we can then substitute in the x and the h of x value and solve for k. So that's what we'll do first, but let's finish reading the question. So after we do that, we'll have a model for the height, and then the question we're looking for is how long is this rail AB? Right, so once we have the model, that will be a simple step right after. So let's finish finding this model. Right, so that's the model, and we've determined that there's a point at 1.8, 2.43. So we're given 2.43 is like the maximum height, so the turning point, and then we worked out 1.8 because we know that the width of the base of the arch is 3.6, as we acknowledge that this is the x-intercept form, and then we half that to get the x value of the turning point. So if you don't know much about your quadratic graphs, this question would be quite challenging. But we do, so let's press on. So we can now substitute the above point to solve for k. Or substitute the above point in h of x, right, in the function h of x, and then solve for k. So here the x value is 1.8, and the h of x value, or the height, is 2.43. So 2.43 equals k times x, which is 1.8, times 3.6 minus x, which is 1.8. So let's simplify and solve for k. So 3.6 minus 1.8 is 1.8. 1.8 times 1.8 is 1.8 squared. So k equals 2.43 divided by 1.8 squared, which is 0.75. So hence, the model is actually exactly 0.75 x times 3.6 minus x. Right, so we found that scaling factor k. So depending on the value of k, it could have looked something like this. Well, it goes through the origin, so it could have been something like that, or like that. Right, it would change the width, change the height. And now using this function, what are we looking for? So the rail is positioned 0.5 meters above the wall, and we're looking for the width. So we need to find the x value of A and B, right, and find the difference. So we can set the height to be 0.5, so that's the height of the rail, and that will equal height function. And what this is saying is, all right, let's find the x values that this parabola, when this parabola is equal to this height of 0.5. So it's finding the intersection points. So we could do that graphically, right? We could go menu, graph, we graph 0.5, and then we graph our function 0.75 x times 3.6 minus x, bracket, execute, and hit draw. Your window might be messed up like mine, so let's consider what we should change that to. So the x values goes from 0 up to about 4, right? The width. The height goes from 0 up to about 2.5. We're going to exit, draw that again. Oh, what did I do wrong? Oh, what happened here? So y min 0, y max 2.5. That should fix it. There we go. So this looks like the drawing on the right. And to find the x values of those intersection points, we can hit F5, which is gsolve. We hit F5 again for ISCT, intersection. And here it says x equals 0.195, and I hit the little arrow to the right, x equals 3.4. So x equals 0.195, or x equals 3.4. And so then the difference would be, so length AB is 3.4 minus 0.195, which is about 3.2 meters. So that's solving it graphically. The other way is when we get to here, right, we've put in 0.5 as the height, and we've equated that to our height function, is to expand this out and get a quadratic equation. So let's do that as well. So we get 0.5 equals, now 0.75 times, menu, 0.75 times 3.6, 2.7. x, and then 0.75x times minus x is minus 0.75x squared. Now I'm starting to see a quadratic equation emerge, so I'll take everything to the left side. So add 0.75x squared, subtract 2.7x equals 0. Now we have a quadratic equation which we can solve however you like. For example, we could use menu equa for equation solver, F2 for polynomial, degree 2 for quadratic, and we put in the A, B, and C values. So in this case, A is 0.75, B is minus 2.7, and C is plus 0.5. And we hit F1, which is solve, and we get the same answer, right? X is 3.4 or 1.95, or 1.96 rather. And to find the length of AB, we just find the difference. So quite a lot of work for this one, but once you've got the steps down, I'm sure you can do it. So let's just summarize it one more time. So we have a parabolic function, right? A model for the height of an arch. We first had to finish the model, right? We didn't know what k was. So we used this vertex, this turning point, to find k by substituting it in. Right, so that was step 1. Step 2 was to find the x values of that rail AB, or the endpoints. And to do that, we set a height function, a height model, equal to the height of the rail, and then solved for x, which you could do graphically, right? Or you could do algebraically and then solve the quadratic equation. Last step was to find the length by subtracting the x values.